Hello ladies and gents, this is Daniel for Rock the JVM, and in this video I'm going to show you a nice feature of Akka Typed called Akka Discovery. So for this video I'll assume that you know the basics of Akka Typed. I'm not going to go too rocket science on this one, and as always I'll recommend that you write code with me to see this feature for yourself, and whenever you need to refresh your memory about this technique, just refer back to the video or to the written form at the blog with the link in the description. Now, by the way, I also teach Akka Typed here at Rock the JVM, so you can find a link to this video if you're interested. Alright, so here I have a small application with a main method. I call this Akka Discovery, and I'm going to show you the nice feature that will allow you to find actors within the actor system without necessarily having their actor refs that you can use to send messages to them. I'm using Akka 2.6, Akka Typed, so I'm going to show you here in this latest version of Akka at the moment of this recording. So for this use case, I'm going to give you a demonstration based on a fictitious IoT application where we have a bunch of sensors, and we have these sensors as actors. We also have these sensors managed by some sort of sensor controller, which gives heartbeats to this array of sensors. So this sensor control will send regular messages to these sensors, and these sensors will send messages or send their data to some form of data aggregator. Now, the gist is that this data aggregator might change over time. So the data aggregator might be used for different purposes. You might be interested in doing some graph visualizations or some machine learning or some other form of data processing. So the gist is that this data aggregator might change over time, and these sensors have no way of finding which data aggregator is the latest at that particular moment. And besides all of that, we're also going to have a guardian actor, which we're going to use to spawn all of these at the same time. Now, for some reason in our system, there is a disconnect between the guardian actor, which spawns the data aggregator, and the direct access to these sensors themselves. So there's a disconnect here. And the disconnect means that the guardian actor does not know the actor refs of these sensors, so the guardian actor cannot pass the actor ref of the new data aggregator should it ever change. So the guardian actor cannot pass the aggregator to all these sensors. So these sensors need to be made aware through some other mechanism, and we're going to use Akka Discovery. And the technique for using that is called a receptionist. All right, so here's the deal. I'm going to define some objects with some apply factory methods to spawn all of these behaviors. So I'm going to have an object, I'm going to call this data aggregator, and I'm going to define an apply method that will give us a behavior, and I'm going to import behavior from Akka Typed, and I'm going to create a behavior of, and I'm going to create some data structure that will signify a sensor reading. So I'm going to have a case class. I'm going to call this sensor reading, and I'm going to have an ID for the sensor, which is a string, and some value, which is a double. You can generalize this as much as you want, and I'm going to return a behavior of these sensor readings. For now, I'm going to leave this unimplemented. I'm going to create another object. I'm going to call this sensor, and I'm going to, again, define an apply method. So I'm going to have my apply with an ID as a string. So this will be the ID of the sensor, and this will be a behavior of, and I'm going to define a trait that this sensor will respond with. So this is the sensor, let's call this section, and I'm going to have a trait called sensor command, let's say, and I'm going to have a bunch of commands that I might use here. Let's say a case object, the sensor heartbeat, that the sensor control will pass to these sensors to tell them to send their readings to the data aggregator. So this extends sensor command. And I'm going to make this apply factory method return a behavior of this sensor command. Sensor command. And I'm going to leave this blank, and I'm going to also create another method to spawn the controller. I'm going to call this controller. And this is going to be a behavior, and I'm going to use not used in this case because the controller itself doesn't really receive any messages. So I'm going to leave this blank. I'm also going to create my val guardian, and this will be an behavior of, again, not used. And I'm going to use a behavior.setup. So behavior.setup behaviors. I forgot the API. So this is going to be behaviors.setup, and I'm going to take the actor context, and I'm going to spawn the sensor controller and the data aggregators, plural. So I'm going to have my, let's call this sensor controller as context spawn. I'm going to use sensor.controller. This will not take any arguments. I'm going to call this controller. And once this starts, this will send messages to sensor actors. So I'm going to keep this blank. So this is just the controller for the sensors. And I'm going to spawn some data aggregators. I'm going to have, let's call this data ag1 as context spawn. I'm going to use data aggregator applied. I'm going to call this data ag1. And I'm going to copy that. I'm going to call this data ag2. And I'm going to show you how we can publish the fact that the aggregator that we want to use is this data ag2 instead of the data ag1. So I'm going to add some to-dos here for me to, first of all, publish data aggregator 1 so that these sensors are aware that this was changed. And also, after a certain while, I'm going to publish data ag2 as the new data aggregator to be used. And finally, I'm going to call behaviors.empty. I don't want to use anything in the Guardian actor. Now, in main, I'm going to spawn my actor system. Let's go have my system as actor system. So actor system. And I'm going to use the Guardian behavior. I'm going to call this Akka Discovery. And I'm going to say system. After 20 seconds or so, I'm going to call terminate. I'm going to add some to-dos here for me too. Okay, cool. Let's start implementing these gaps. And I'm going to start with the data aggregator because it's the most disconnected from these sensors. So I'm going to keep a map of which sensor read which data. So I'm going to define a method. I'm going to call this active. And I'm going to pass some arguments here. I'm going to call this, let's say, latest readings as a map between the ID of the sensor and the reading of that particular sensor. And this is a behavior of sensor reading. So this is the technique that I teach in the Akka Typed course, which is the so-called stateless actors, so that we don't keep variables, mutable variables, but rather change behaviors to another call of the methods with different arguments. And here in this latest readings, we are going to return a different map depending on whatever sensor reading we obtain. So I'm going to return behaviors.receive, and behaviors.receive takes a 2-argument lambda, which is the actor context and the sensor reading. The actor context, as you well know, is a rich data structure that will give you access to Akka actor functionalities. And I'm going to first of all deconstruct the reading into the ID and the value. So I'm going to say val, I'm going to use some pattern matching here, or you can say just the ID as reading.id and value as reading.value. By the way, if you are interested in doing these pattern matching from a single declaration, you can say val sensor reading with ID and value equals reading, which does some pattern matching pretty nicely here. That's the fancier way of doing that. And I'm going to create my, let's call this new readings as latest readings plus, and I'm going to make a new association between the ID and the value. So I'm going to say ID is associated to the value. Now, I'm going to feed this latest to a graph or something like that, or print them out, or do something with this latest data. So this is the display part. And I'm simply going to log them for brevity. So I'm going to say context log info, and I'm going to use an s-interpolated string, and I'm going to add a little tag here. So I'm going to use context self path name as the identifier of this data aggregator, because we're going to change it over time. And then I'm going to say latest readings, and I'm going to inject the new readings as a map. I don't actually need to expand upon that. And then I'm going to change my behavior to a new call to active. So this will be a new behavior where the readings has changed. So I'm going to have new readings. So this is the true behavior of the actor, and here in apply, when you spawn the data aggregator, I'm simply going to call active with an empty map. Cool, so this was the data aggregator. Now, we need to complete the sensor's apply method, which is the actor that denotes a single sensor, the actor controller, which is going to manage all these sensors, and finally the guardian logic that will create these data aggregators, which we've already done, and also the mechanism by which we're going to make these sensors aware that the data aggregators were changed. Now, here's the deal. I'm going to start with the guardian actor first because this is the easiest part of the receptionist or the discovery pattern. So here I'm going to use something that's called a receptionist, and I'm going to use that to publish the fact that data aggregator 1 is available. And data aggregator 1 is considered to be available by associating it to a identifier or a key. That is called a service key. And to do that, it's often a good practice to define the service keys in the object of the actor that you want to spawn. And I'm going to create a val here. I'm going to call this service key. And I'm going to use service key with all caps here. Notice that service key is an object here from Akka Typed Receptionist. So I'm going to create this service key, and I'm going to type it with the type that this actor receives, which is sensor reading. So service key for sensor reading. And I'm going to give this an identifier. Let's call this data aggregator. Now, this service key is a unique identifier at the Akka level that we can use to interrogate the actor system and get back an actor ref that we can use to send messages to. So this will be our way of identifying data aggregators. Now, I'm going to have to publish the data aggregators first by saying context system receptionist, which is available for any actor system, and I'm going to send a publish message, which is called receptionist with a capital R, .register. And I need to pass the service key and the actor ref associated to that type, which is data aggregator service key. So to this key, I will associate data ag1. So this is how I can publish the fact that data ag1 is associated to this service key. Now, from the other side, from the sensor's side, I can then interrogate what is allocated to the service key, fetch the data aggregator, and then use it to send messages to that. So this can be done transparently, regardless of the fact that the guardian cannot directly communicate with these sensors. So this is very, very powerful. And here in the guardian actor, I'm going to change the data aggregator to data ag2 after a certain time. So I'm going to say, let's change the data aggregator after let's say 10 seconds or something like that. And I'm going to say thread sleep for 10 seconds. I'm going to use the poor man scheduler, and I'm going to use context log info, and I'm going to say string like guardian, and I'm going to say changing data aggregator. And I'm going to first deregister data ag1 from the service key, and I'm going to register data ag2. So I'm going to say context system receptionist. So receptionist tell, and I'm going to say receptionist.deregister. I'm going to use the same arguments, data aggregator service key and data ag1. And finally, I'm going to use the same kind of registration call to register data ag2 in this case. And my to-do is done. So after 10 seconds, data ag1 was replaced with data ag2. Now, in the meantime, the sensors should be working and setting data to whatever data aggregator is registered at that point. So we should be seeing some logs associated to data ag1. And after 10 seconds, automatically or transparently, we should start seeing logs from data ag2, regardless of whether data ag2 was not directly sent by the guardians to the sensors, but the sensors will pick the data aggregator by themselves. So let me get back to this sensor. I'm going to use the apply method, and I'm going to have behaviors.setup because I need to somehow subscribe to the fact that the service key must send whatever actor is updated to me, so back to me. So I'm going to use my context as my argument here. And now I'm going to write something that's going to be slightly complicated. Basically, I'm going to subscribe to the receptionist using the service key. So, in other words, whenever the receptionist is registered with an actor on this service key, whoever is subscribed on the service key will be notified that the new actor ref was allocated to this service key. So I'm going to say context system receptionist, which is the same actor, and I'm going to send a message which is called receptionist.subscribe. And this takes two arguments. First of all, the service key to which I'm subscribing, which is the same data aggregator service key, and the subscriber, which is an actor ref of a particular type, which is a receptionist.listing. Now, I would like this to be myself, so this sensor, but the actor ref is an actor of sensor command, not receptionist.listing. So I have to find a way to turn this receptionist listing into a sensor command. So I'm going to create a message adapter, which you have seen here on Rock the JVM as well. So I'm going to create the message adapter technique. So use a message adapter to turn a receptionist listing into a sensor command. So here I'm going to have a case class. I'm going to call this change data aggregator. And this ag is going to be an option of actor ref of sensor reading, which is the type that the data aggregator supports. And this extends sensor command. And I'm going to use a message adapter to change the receptionist's listing message into one of these case classes. So I'm going to have my val, I'm going to call this receptionist subscriber as context.messageAdapter. And this takes a function between the type that I want to transform into the sensor command. So I'm going to have a case for data aggregator.serviceKey.listing. I told you that the service key contains its own type. So listing for a set of actors. Now I'm going to turn the set into a change data aggregator containing just an option of actor ref. So I'm going to have change data aggregator using set.headOption. Now, this receptionist subscriber is an actor ref of the type that I want to transform, which is receptionist.listing. Now, because this is of the right type, I can use this one as an argument to the subscriber. And the message adapter, if you want a quick gist, this receptionist subscriber is a child actor that will receive the listing that I was talking about, and the receptionist subscriber will send the change data aggregator back to me. So I'm going to have to handle this change data aggregator once it's being transformed. So I'm going to write another handle here, which is, let's call this active or active sensor, which will take an ID as a string and the aggregator that I have so far, so the aggregator as an option of actor ref of sensor reading, yes, and this will be a behavior of type sensor command. And for now, I'm going to leave this blank, and I'm going to return this active sensor with ID and none at the beginning. So whenever I receive this change data aggregator after the transformation done by the receptionist subscriber, I'm going to have to change whatever aggregator I have assigned so far. So I'm going to have my behaviors dot, and I'm going to use receive message because I don't really need to do anything with the actor context. And in case I get my sensor heartbeat, then I'm going to add a new reading and send it to the aggregator. So I'm going to say aggregator.forEach, assuming this might have an option here. I'm going to say _tell. So whatever the aggregator might have been in this option, I'm going to tell it. I'm going to pass a sensor reading containing the ID of this sensor and some value. I'm going to generate it randomly. So I'm going to say random from Scala util.next double. And I'm going to multiply that by 40 to sound like a Celsius temperature or something like that. And I'm going to have behaviors.same because I'm not changing anything with my data. Now, in case I receive this change data aggregator message, so change data aggregator with a new ag, then I'm going to change my aggregator. So I'm going to swap this for a new behavior obtained by a new call to active sensor. So I'm going to say active sensor with the same ID and the new ag as the argument. Cool. So this was the sensor logic. Now, the controller will simply be a behaviors.setup where I spawn a bunch of sensor actors, and I'm going to simply regularly send a heartbeat messages to them. So I'm going to say behaviors.setup, and given an actor context, I'm going to create my sensors, and I'm going to say, let's call this 1 to 10 dot map, and for every sensor I'm going to say context spawn, and I'm going to use the sensor.apply. So sensor applied to the context, to the ID I, which is an int. I need to turn this into a string, so I'm going to use an s-interpolated string. Let's call this sensor underscore I, and I'm going to use sensor underscore I as the name as well, as an s-interpolated string. So this is the sensors list. And then I'm going to repeatedly send messages to them. So send heartbeats, let's say every second or every 2 seconds. So every second. And I'm going to use context system scheduler, and I'm going to say schedule at fixed rate. I'm going to use 1 second as the initial delay, and I need to have access to the second method, so I'm going to go ahead and import that. So import Scala concurrent duration everything, which will give me access to the second extension method. And I'm going to schedule the, I think the second argument is the interval. Okay, so I'm going to use the interval 1 second as well. And the second argument is going to be a 0 lambda that will simply say context log info. I'm going to call this heartbeat. And for every sensor, I'm going to send the sensor heartbeat message. So sensors.forEach. And for every sensor, I'm going to send it the message sensor heartbeat. Now, the scheduler needs an execution context, so I'm going to import that. So import context.execution-context. And finally, I'm going to have behaviors.empty. Now, because I'm using the execution context, this lambda will be executed asynchronously on top of this thread pool, essentially, which will, I think this will not allow my access to the actor context outside of the actor scope. So this will probably throw some exception. So I'm going to be safe and save the logger. So I'm going to have my logger as context.log. Then I'm going to say logger info heartbeat here. Okay. Do we have any other to-dos here in main? Let's say I want to finish the system after, let's say, 25 seconds or so. So here at first, we have data ag1 should log all the data for 10 seconds, so roughly 10 heartbeats. And after 10 seconds, the data aggregator was swapped with data aggregator 2. So data aggregator 2 is going to be the one to log. And then after, let's say, 10 more seconds, I'm going to shut everything down. So I'm going to say system scheduler schedule once, and I'm going to say after 20 seconds, I'm going to use system terminate. Now this also needs an execution context, so I'm going to import system.execution context. Okay, Cool. So the behavior should work as follows. Once the system starts, this will start the sensor controller. Now, I don't really need this variable. I can simply spawn the controller as is. And the sensor controller will spawn 10 sensors that will simply wait for the controller to send them heartbeats. So this controller will send them heartbeats every second. Now, in the meantime, the guardian actor will create a data aggregator and register it with the service key, which the sensors should pick up automatically. And after 10 seconds, the data aggregator should be swapped with data aggregator number 2. So the data ag2 tag should start being the one to print the sensor data transparently, so without any hiccup in the sensor activity. Cool. Let's try to run this and let's see what we got. Okay, so we're going to have a lot of logs here. So we have a bunch of heartbeats. Notice that data ag1 is the one to print data from all the sensors because we sent 10 messages at the time. Notice that we've changed the data aggregator and suddenly the data ag2 is the tag to print all the sensors. And after 20 seconds, we should have the actor system and the application shut down. So notice that the data aggregator was swapped transparently without impairing the sensor activity. So notice that in the middle of the application, the guardian says changing data aggregator, and the sensor controller as well as the sensors themselves continue pushing data to the new data destination. So this is the Receptionist pattern and Akka Discovery. All right, so I hope you liked the Akka Discovery and the Receptionist pattern in this video. If you liked it, go ahead and click the like button for me and subscribe to the Rock the JVM channel for more videos like this. Check out the Akka Typed course here at Rock the JVM, as well as hundreds of hours literally on everything in the Scala ecosystem, including Akka. So until next time, I'm Daniel, signing off.